The idea of humans traveling to Mars has long captured the imagination of science fiction writers, astronauts, and dreamers alike. For decades, we've looked up at the red planet and wondered, could we one day live there? Could Mars become the next home for humanity? With the rapid advancements in space technology and growing interest from government space agencies and private companies, the idea of colonizing Mars is no longer just a distant dream. It is becoming a real, feasible possibility. Mars, the fourth planet from the Sun, has long been considered the most Earth-like planet in our solar system. It's not just the planet's size and distance from the Sun that make it an attractive target for exploration. It's also the presence of water, its geological history, and the possibility of a future atmosphere. These factors, combined with the progress being made by space agencies like NASA and private ventures like SpaceX, have propelled Mars to the forefront of space exploration. Why Mars? What makes it a prime target for colonization? Before we dive into the details of what it would take to colonize Mars, it's important to understand why this planet has captivated scientists for so long. Mars offers several unique features that make it an ideal candidate for exploration and, ultimately, habitation. Proximity to Earth. Mars is the closest planet to Earth that has the potential to support human life. While other planets like Venus or Jupiter are too inhospitable due to extreme temperatures, lack of atmosphere, or high levels of radiation, Mars sits in a sweet spot. It's far enough from the Sun to have seasons similar to Earth, but not so far that it is too cold for liquid water to exist. At its closest approach, Mars is about 54.6 million kilometers, 33.9 million miles, away from Earth, roughly 1/10 of the distance to Neptune. This proximity makes it the most accessible planet for human exploration and colonization. Water resources. One of the most significant challenges for colonizing another planet is the availability of water. Water is essential not only for drinking and food production, but also for generating oxygen and fueling rockets. Mars has vast amounts of water, primarily in the form of ice, hidden beneath its surface and at the polar ice caps. In 2008, NASA's Phoenix mission confirmed the presence of water ice on Mars, and later missions like Curiosity and Perseverance have uncovered more evidence. This water could be extracted and purified for use in future missions, reducing the need to bring large quantities of water from Earth. Atmosphere and gravity. While Mars doesn't have the thick atmosphere that Earth does, it still has a thin atmosphere primarily composed of carbon dioxide. The atmosphere on Mars is about 1% the thickness of Earth's, meaning that humans would need to rely on pressurized habitats or wear spacesuits outside. However, the presence of carbon dioxide in the atmosphere offers the potential for terraforming efforts or even creating breathable air using chemical processes. The gravity on Mars is about 38 bacterial, 8% that of Earth's, which is enough to allow for the human body to function, though long-term effects on human health would still need to be studied. Geological features and soil. Mars has a rich geological history, with ancient riverbeds, volcanic mountains, and vast deserts. Its surface shows evidence of once having liquid water, as well as possible ancient lakes and oceans. The soil on Mars, while not directly fertile, is rich in minerals like iron, magnesium, and sulfur, which could be used for agriculture with the right techniques. Researchers are experimenting with ways to grow food on Mars using its soil, possibly in combination with nutrients brought from Earth or in hydroponic systems. Scientific interest. Mars has been a subject of fascination for scientists because of its potential to answer some of the most fundamental questions about our solar system and the possibility of life beyond Earth. The discovery of ancient water on Mars suggests that the planet may have once harbored life. The question remains, was there ever life on Mars? And could it have survived in some form? These questions are at the heart of ongoing missions like Perseverance and Curiosity, which are exploring Mars's surface to search for signs of past life. Understanding Mars' geological and climatic history is not only important for the scientific community, but also for planning a sustainable human presence on the planet. The first steps, NASA, SpaceX, and other key players. While the dream of colonizing Mars may seem like a far-off fantasy, there are already significant efforts underway to make it a reality. Both governmental space agencies such as NASA and private companies like SpaceX have set their sights on Mars as the next great frontier for humanity. NASA's Mars Missions NASA has been at the forefront of exploring Mars for decades. The Mars Pathfinder mission in 1997, followed by the Spirit and Opportunity rovers, helped scientists gain invaluable insights into the planet's surface. More recently, the Curiosity rover and Perseverance rover have been investigating Mars' past environment, geology, and potential for life. Perseverance, which landed on Mars in 2021, is particularly notable for its sample collection program, which aims to bring Martian soil samples back to Earth. NASA's Artemis program, which aims to return astronauts to the Moon, will also serve as a stepping stone for future human missions to Mars. SpaceX and the vision for Mars. Perhaps the most ambitious plan for Mars colonization comes from SpaceX, the private aerospace company founded by Elon Musk. SpaceX's vision for Mars is nothing short of revolutionary. Musk has repeatedly stated that his goal is to make life multiplanetary, with Mars as the first viable destination for human settlement. In 2020, SpaceX successfully launched its Starship prototype, a fully reusable spacecraft designed for long-duration missions to Mars. Starship is central to SpaceX's plan for interplanetary travel and colonization. The spacecraft is intended to carry up to 100 people and large amounts of cargo, making it possible to transport entire colonies to Mars. SpaceX plans to send its first crewed mission to Mars within the next decade. While challenges remain in terms of technology, safety, and life support systems, SpaceX's aggressive timelines and ability to innovate at a rapid pace have made Mars colonization seem like an attainable goal. Musk's vision involves not just landing on Mars, but building a self-sustaining colony that can eventually grow its own food, extract water from the Martian surface, and produce the resources needed for long-term habitation. Musk has even proposed the idea of terraforming Mars, using methods like releasing greenhouse gases to warm the planet and thicken its atmosphere over time. International collaboration. While SpaceX and NASA are leading the charge for Mars exploration, other countries and private companies are also making significant contributions. The European Space Agency, ESA, has its own plans for Mars exploration, with missions like the ExoMars rover in collaboration with Russia's Roscosmos. China, too, has made strides in its space exploration program, successfully landing the Zhurong rover on Mars in 2021 as part of its Tianwen-1 mission. The growing international interest in Mars exploration could lead to greater collaboration between space agencies, pooling resources and knowledge to make Mars colonization a reality. Overcoming the challenges, what needs to be done for Mars colonization? While the idea of colonizing Mars is tantalizing, the reality is that we face immense challenges in making it happen. The red planet presents an environment so hostile to human life that every aspect of a Mars mission, from the journey there to long-term habitation requires innovative solutions, groundbreaking technology, and immense resources. The path to Mars colonization is fraught with obstacles, and overcoming them will take decades of research, testing, and international collaboration. The journey to Mars. How do we get there? One of the first hurdles in colonizing Mars is simply getting there. The distance between Earth and Mars varies depending on the relative positions of the two planets in their orbits. At its closest, Mars is about 54.6 million kilometers, 33.9 million miles, away from Earth, but at its furthest, it's about 401 million kilometers, 249 million miles. Traveling these vast distances will require spacecraft that are capable of carrying large crews, supplies, and equipment, and doing so efficiently. Spacecraft like SpaceX's Starship are designed with this challenge in mind. Starship's fully reusable design and massive payload capacity make it well-suited for long-duration missions to Mars. However, sending humans to Mars will take anywhere from 6 to 9 months, depending on the alignment of the planets. During this journey, astronauts will face a range of challenges, from prolonged exposure to radiation to psychological stress from isolation. Radiation is one of the most serious concerns for a Mars mission. Without Earth's protective magnetic field and atmosphere, astronauts will be exposed to high levels of cosmic radiation and solar radiation. Prolonged exposure to this radiation can increase the risk of cancer and other health issues. To mitigate this risk, spacecraft will need to be equipped with advanced shielding, and future habitats on Mars will need to be built underground or with thick walls to protect inhabitants. Life support systems, creating a habitable environment on Mars. Once humans reach Mars, the next challenge is creating a habitable environment. The Martian atmosphere is thin, composed mostly of carbon dioxide, and offers no breathable oxygen. Temperatures on Mars can drop to as low as 125 degrees hours, 195 degrees at the poles, and the planet has frequent dust storms that can cover vast areas. With such an inhospitable environment, it is essential to establish life support systems that can sustain human life. One approach is to create pressurized habitats that mimic Earth's atmosphere. These habitats would need to have breathable air, a stable temperature, and protection from harmful radiation. Habitat modules designed by NASA and private companies like SpaceX are already being tested on Earth, and prototypes are being developed for future Mars missions. These habitats could be inflatable, modular structures that are easy to transport and deploy on the Martian surface. They would be equipped with life support systems to regulate oxygen, remove carbon dioxide, and ensure a steady supply of water and food. In addition to pressurized habitats, future Mars settlers would need reliable sources of food and water. While water has been detected on Mars in the form of ice, extracting and purifying it for human consumption will require sophisticated technology. Researchers are working on water extraction systems that could melt Martian ice and filter it for use. Growing food on Mars presents another significant challenge. While hydroponics and aeroponics, soil-less farming techniques, are promising solutions, Mars' gravity and soil composition may make agriculture more difficult than on Earth. Advances in genetically modified crops and closed-loop agricultural systems will be critical to ensuring a stable food supply. Building a self-sustaining colony. One of the ultimate goals for Mars colonization is to create a self-sustaining colony, a settlement that can support itself without relying on resupplies from Earth. This is an ambitious goal, as it requires the development of infrastructure capable of producing food, water, energy, and materials from local resources. In situ resource utilization, ISRU, will be essential for this process. ISRU involves using the resources found on Mars, such as water, carbon dioxide, and minerals, to create the materials needed for the colony. For example, carbon dioxide from the Martian atmosphere could be converted into oxygen for breathing and methane for fuel. Mars's soil contains essential minerals like iron, magnesium, and sulfur, which could be used to manufacture building materials, tools, and even 3D printed structures. Solar power will be the primary source of energy for the colony, as Mars receives less sunlight than Earth, but its surface is still suitable for solar panels. Over time, these technologies will allow the colony to grow without needing constant shipments from Earth. However, developing the systems and infrastructure required for a self-sustaining colony is a massive undertaking that will require years, if not decades, of testing and experimentation. The early days of Mars colonization will likely rely heavily on Earth-based support, with resupply missions and scientific research conducted remotely. The first few years will likely involve creating habitable zones, expanding energy and water systems, and building a reliable food supply chain. The role of artificial intelligence and robotics in Mars colonization. As we look to colonize Mars, it's clear that artificial intelligence, AI, and robotics will play a crucial role. These technologies are already being tested in space missions, and their application on Mars will be even more critical. AI will help manage life support systems, monitor the health of astronauts, and optimize resource usage. Robots will be used for construction, resource extraction, and exploration, performing tasks that would be too dangerous or difficult for humans. Robotic rovers like NASA's Perseverance will continue to play a significant role in scouting locations for human habitats and scientific research. Drones and robotic arms could help assemble structures and equipment on Mars, and advanced AI algorithms will help ensure that all systems are running efficiently. In the future, robots could even work alongside humans, performing hazardous tasks or building structures while astronauts focus on more complex tasks. But AI and robotics also present new challenges. We'll need to ensure that these systems are reliable and autonomous, especially given the delays in communication between Earth and Mars. Any malfunction in the system could jeopardize the safety of the colony, so testing and fail-safes will be essential. Furthermore, the development of autonomous systems must go hand in hand with ethical considerations. How will we ensure the responsible use of AI in space exploration? And how will we regulate the use of autonomous robots in building and managing human settlements? Psychological and social challenges of Mars colonization. While the technical challenges of reaching and settling on Mars are daunting, perhaps the most difficult obstacles to overcome will be the psychological and social challenges of living on another planet. Human beings are social creatures, and the idea of sending astronauts to Mars for extended periods, potentially without direct contact with Earth for months at a time, raises serious concerns about mental health, isolation, and group dynamics. Isolation and mental health. The journey to Mars, which will take approximately 6 to 9 months, will be the longest human mission to date. The crew will be confined to a spacecraft for an extended period, and once they arrive on Mars, they will be isolated from the rest of humanity. The isolation and confinement could lead to psychological stress, depression, and other mental health issues. With limited space, few social interactions, and the knowledge that there is no immediate help available, astronauts may struggle with feelings of loneliness and confinement. NASA and private companies like SpaceX are already studying these effects through analog missions, such as the HIC's mission in Hawaii, where participants simulate living on Mars for months at a time. These studies have shown that astronauts need strategies to maintain mental health, such as regular exercise, communication with loved ones, and activities to relieve stress. Researchers are also exploring the use of artificial intelligence and virtual reality to help astronauts feel connected to Earth and maintain a sense of normalcy. These early psychological studies will be crucial in designing missions that can support astronauts' mental well-being during long-term stays on Mars. Group dynamics and social cohesion. Living in close quarters for extended periods of time will also present challenges in terms of social dynamics. The small, isolated nature of a Mars colony means that interpersonal conflicts are inevitable. With a small crew, every member will have to work closely with one another, often under stressful and high-stakes conditions. The ability of astronauts to work together as a cohesive team will be critical to the success of a Mars mission. Studies of group dynamics and space analogs have shown that teamwork and leadership are key factors in ensuring the success of long-duration missions. In the confines of a Mars habitat, astronauts will need to rely on one another for support, cooperation, and problem-solving. Communication skills will be crucial, especially since there will be a delay in messages sent from Earth, and astronauts will need to solve many problems independently. Ensuring that crew members have the training and support to manage stress, resolve conflicts, and maintain effective communication will be essential. Social cohesion will be the foundation of a successful Mars colony. If a crew can't work together effectively, the mission and the colony could fail. The long-term sustainability of a Mars colony. One of the biggest questions surrounding Mars colonization is whether a human presence on Mars can be sustained over the long term. Will humans be able to survive and thrive on Mars, or will we be forced to abandon the idea of a permanent colony? Self-sufficiency, the key to long-term survival. The goal of Mars colonization is to create a self-sustaining colony, one that can support itself without relying on supplies from Earth. This would require developing technologies that can recycle water, oxygen, and waste, as well as methods of food production on Mars. Currently, any human mission to Mars would rely heavily on resupply missions from Earth. But as the colony grows, it will be essential to make use of local resources. In situ resource utilization, ISRU technologies, will play a crucial role in making this a reality. One of the most important resources to develop is water. While there is evidence of water ice on Mars, extracting it and making it usable for drinking, farming, and industrial purposes will be a major challenge. One solution might be to use local ice deposits, which can be melted and purified. Technologies like reverse osmosis filtration could be used to ensure that water is safe for consumption. Solar-powered extraction systems, which could melt water ice and extract water from the Martian atmosphere, will also be essential for long-term sustainability. Food production will also need to be developed on Mars. Early settlers could rely on stored food for the first few years, but over time, the colony will need to produce its own food. This could be achieved through hydroponics, growing plants in water without soil, or aeroponics, growing plants in air with misted nutrients. The success of these agricultural systems will depend on the ability to provide sufficient light, nutrients, and water. It's also possible that genetically modified crops will play a role, as certain plants might need to be tailored to grow in the harsh Martian environment. Energy production. A Mars colony will require a reliable source of energy to power life support systems, habitats, and equipment. While solar power will be the primary energy source on Mars, the amount of sunlight that reaches the surface is only about 43% of what we receive on Earth. This means that solar panels may not be as efficient during the long, cold Martian winters. To address this, Mars habitats could be designed with thermal energy storage systems, using batteries or molten salt to store heat and power systems when the sun is not available. Additionally, nuclear power could play a role in providing continuous, reliable energy to the colony. The development of advanced power generation methods, such as small modular nuclear reactors, could provide a steady supply of electricity and heat. This would ensure that the colony remains functional even when the Martian dust storms block sunlight for extended periods. The role of artificial intelligence and automation. As we look toward the future of Mars colonization, the role of artificial intelligence, AI, and automation becomes more important. Due to the difficulty and expense of sending humans to Mars, many of the tasks required to establish a functioning colony will be carried out by robots and AI systems. These systems will perform a variety of tasks, from building habitats and infrastructure to conducting scientific experiments and monitoring the health of the colony's inhabitants. Robotic rovers, much like NASA's Curiosity and Perseverance rovers, could be used to explore the Martian surface, scout for resources, and even assist in construction. Robots could also be used to assemble habitat modules, extract resources from the planet, and help with food production. AI systems could manage everything from life support systems to medical care, ensuring that the colony operates smoothly even in the face of unpredictable conditions. In addition, AI-powered virtual assistants could help astronauts stay connected with their families on Earth and assist with decision-making. With the long communication delays between Earth and Mars, AI systems will be critical for decision-making, especially in emergencies when immediate guidance from Earth is not possible.